Thank you so much for that introduction, Thomas, and thank you all for being here. What Thomas failed to mention is that most of the laughter raised by my book, Aristotle's Revenge, has been laughing at the book rather than, I hope I'm joking. Just because it's not funny doesn't mean it wasn't a joke. Just a courtesy chuckle would be. So the title of my talk, the main title is What is Matter? I thought of giving it a cute title like What's the Matter? And I realized that first of all, that would be kind of lame, and second of all, it might draw a totally different audience. People would come expecting a self-help lecture or a pop psychology lecture or something. So I just stuck with the boring old What is Matter? And it's worth commenting a little bit on my subtitle, From Aristotle to Quantum Mechanics and Back Again, because to give credit where it's due, that's an homage to a book by, not one of his better-known books, but still an important book by Etienne Gilson, 20th century Thomist, who wrote a book with the title From Aristotle to Darwin and Back Again, by which he tried to show that there was more continuity between the Aristotelian way of thinking about biology and the modern way of thinking about it than people often realize. So what I'm trying to do is something similar, but in this case in the context of physics and especially quantum mechanics rather than biology. So that's the source of that subtitle. I've got to give credit to Gilson. Okay, I trust everybody's got the handout that was available at the back or before you come in the door. And that'll give us a little bit of a roadmap to our discussion this evening. So, to get into the talk itself, then, nothing could be more familiar than material objects: tables and chairs, rocks and trees, dogs and cats, and human bodies. But what exactly is matter? The history of philosophy and science shows surprisingly little consensus on how to answer that question. As Stephen Toulmin notes in the article on matter in the Encyclopedia of Philosophy, quote, "It is highly doubtful whether one can isolate a single concept of matter shared by, say, Anaximander and Aquinas, Democritus and Descartes, Epicurus and Einstein," unquote. Yet the answer could hardly be more significant for the two fields. Some of the central problems of philosophy ride on it. Consider, for example, the ancient controversy over whether mind is reducible to matter. Materialists say that it is, and dualists say that it is not. But obviously, you have to have some idea of what matter is in the first place before you can go on to judge that one or the other of these two views is correct. Or consider physics, which is often described as more fundamental than the other sciences insofar as it studies not just this or that specific kind of material thing, but the building blocks of all matter. Obviously, you first have to have at least some idea of what matter is in order for this characterization to be informative. In this talk, I'll be discussing what I take to be the three historically most influential and important accounts of the nature of matter. The first is the Hylomorphism, originally developed by Aristotle in response to the views of his predecessors from Thales to Plato, and later refined by Thomas Aquinas and other scholastic thinkers. Hylomorphism, and if you're not familiar with that word, it's there on the handout. You can Google it later. I should note that it's often spelled hylomorphism with an O rather than an E. This is something that only Thomists care about. I was actually once witness to an email dispute between a couple of Thomist scholars over what the correct spelling ought to be, the correct transliteration. So anyway, mercifully, I won't get into that here. Okay. The second of these views of matter I want to discuss is what you might call the mechanical philosophy, the mechanistic world picture that the founders of early modern philosophy and science put in place of hylomorphism. And the third is the account of matter offered by quantum mechanics. I will not only defend hylomorphism, but will argue that its rival, the mechanical philosophy, is plagued by insuperable problems, and that quantum mechanics not only is compatible with hylomorphism, but if anything vindicates, in order to make a somewhat less ambitious claim anyway, points back in the direction of something like Aristotle's hylomorphism. Okay, so let me start by giving a little bit of the background to hylomorphism as it was first developed by Aristotle, and this is Roman numeral 2 there on your handout. A little bit of the early history of philosophy and really the earliest history of Western science that predated Aristotle and against which he was reacting. Hylomorphism occupies the middle ground between two extremes that had developed in pre-Socratic philosophy. What's called by scholars sometimes the dynamic monism of Heraclitus and the static monism of Parmenides and Zeno. Heraclitus denied the permanence and unity of everyday objects, And to illustrate his idea, I'll borrow an example from physicist Richard Feynman. This is a passage from his famous lectures on physics, where he gives the following lucid description of the evaporation of a glass of water. I'm going to quote him at some length, so that at the very least, if you close your eyes, you can pretend you're at a Richard Feynman lecture rather than a Feser lecture, and I'm sure that'll be an improvement. So to quote Feynman, he says, quote, "Above the surface we find water vapor, which is always found above liquid water. In addition, we find some other molecules. Here, two oxygen atoms stuck together by themselves, forming an oxygen molecule. There, two nitrogen atoms also stuck together to make a nitrogen molecule. Air consists almost entirely of nitrogen, oxygen, some water vapor, and lesser amounts of carbon dioxide, argon, and other things. So above the water surface is the air, a gas containing some water vapor. Now, the molecules in the water are always jiggling around. From time to time, one on the surface happens to be hit a little harder than usual and gets knocked away. Thus, molecule by molecule, the water disappears. It evaporates. But if we close the vessel above, after a while, we shall find a large number of molecules of water amongst the air molecules. From time to time, one of these vapor molecules comes flying down to the water and gets stuck again. So we see that what looks like a dead, uninteresting thing, a glass of water with a cover that has been sitting there for perhaps 20 years, really contains a dynamic and interesting phenomenon which is going on all the time. To our eyes, our crude eyes, nothing is changing. But if we could see it a billion times magnified, we would see that from its own point of view, it is always changing. Molecules are leaving the surface, molecules are coming back. Not only does the water go into the air, but also from time to time, one of the oxygen or nitrogen molecules will come in and get lost in the mass of water molecules and work its way into the water. Thus, the air dissolves in the water. Oxygen and nitrogen molecules will work their way into the water, and the water will contain air," unquote. Okay, so that's a long block quote from Richard Feynman. Now, though the terms of this description are modern, I think that Heraclitus would interpret it as a fine illustration of his basic claims. I hasten to add, that's not what Feynman was trying to do. I'm using this modern example as what I think Heraclitus would say, that's confirmation of what I was saying. Common sense would regard the water in the glass as a single unified substance that persists over time and can be sharply distinguished from what surrounds it. But in fact, Heraclitus would say it is an aggregate of constantly changing parts that persists no longer than any particular configuration of the parts does, and the boundaries of which blur into those of its surroundings. Indeed, for Heraclitus, the only genuinely abiding substance is the world as a whole, of which the ordinary objects of our experience are merely the ever-shifting appearances. To be sure, again, I'm not saying that Feynman's description actually vindicates Heraclitus' dynamic monism, and that was certainly not what Feynman himself was trying to do. And in fact, the scientific evidence can be given alternative philosophical interpretations, as we'll see. The point is just that it illustrates Heraclitus' claim that all reality is in flux, and there are no sharp boundaries between objects. Okay, that's a typically Heraclitean position. And one of the two extremes we're going to see that Aristotle reacts against. Okay. In any event, if such empirical considerations might at least seem to offer support to Heraclitus, Parmenides and Zeno notoriously appeal instead to abstract rational argument in support of their contention that it is change and multiplicity rather than permanence and unity which are illusory. So take Parmenides first. He argued that for change to occur would require non-being to give rise to being. For example, when the water in the glass cools, the coolness has to go from non-being or non-existence to being. But for being to arise from non-being, Parmenides argues, is essentially for something to come from nothing. And from nothing comes nothing. Therefore, Parmenides concludes change must be impossible. And if your eyes and ears tell you otherwise, then don't believe your lying eyes and ears. That's Parmenides' famously radical view. But also impossible, in his view, is multiplicity, there being multiple objects in the world. For two or more things to be distinct objects, Parmenides holds, there would have to be something that sets them apart. And in Parmenides' view, this would be the empty space between them. Now, empty space, he argues, would be the absence of anything, or non-being. But precisely because it is the absence of anything, non-being does not exist. It's not a kind of reality. And in that case, empty space does not exist, so that there's nothing that can set apart purportedly different objects. So there really are no different things in the world in Parmenides' view, but just one thing. namely being, undifferentiated and unchanging. This is Parmenides' static monism. There's one reality, being, and what's it doing? It's being. And you can't really say anything more than that. It's undifferentiated, it's unchanging. Change and multiplicity are illusions. Now, Zeno famously defends his teacher Parmenides' view with a set of ingenious paradoxes, of which we'll consider two. In what commentators call Zeno's dichotomy paradox, Zeno asks us to consider a runner trying to get from point A to point B. Common sense supposes that nothing could be easier, but Zeno holds that on analysis, the journey can be seen to be impossible. For in order to get from A to B, the runner first has to get from A to the midpoint between A and B. But to get to the midpoint, he first has to get to the quarter point, and to get to that, he first has to get to the eighth point, and so on ad infinitum. So he can never reach B, and indeed, he cannot even get his foot off of point A, since even to move an inch would require the traversing of an infinite series of ever smaller distances. This sort of paradox shows, in Zeno's view, that motion is an illusion. Okay, and you better hope Zeno is wrong if you're bored already with this lecture, because you're never going to get out of here if he's correct. Zeno's paradox of parts begins with the thesis that if there really were multiple objects in the world, then either they would have size or they would have no size. Those are your two options. But if they have no size, then nothing has any size, because combining any number of things with no size can only ever yield something with no size. Hence, everything would be the same size, namely no size at all. But of course, that's absurd. But supposing that there are multiple things that do have size also leads to absurdity, Zeno argues. For if they do have size, then they are going to be divisible into parts of smaller size, and those of yet smaller parts, and so on ad infinitum. But then they will each have an infinite number of parts, and since the thing is bigger, the more parts that are added to it, it would follow that they are of infinite size. Hence, everything would be of the same size, namely of infinite size. But this too is absurd. And therefore, either way, Zeno argues, the assumption that there are multiple objects leads to absurdity and must be rejected. Imagine if Zeno ran a McDonald's, McZeno's, right? You go in and what do you got, right? Well, we got two sizes, the zero size option and the infinite size option, right? I'll take the zero size. I'm on a diet. And so he gives you an empty tray. Like, there's nothing here. What else you got? He gives you the infinite size. Okay, I'll stop. Okay. I'll be here all week. Okay. Now, Aristotle's hylomorphism is grounded in a crucial distinction he develops when explaining where Parmenides and Zeno's static monism and Heraclitus' dynamic monism each go wrong. And their mistake, he argues, is failing to note the difference between actuality and potentiality. Actuality and potentiality, or act and potency, as we Thomists like to call it, but I'll use slightly less technical language, actuality and potentiality. So consider an ice cube. In describing it, we might note that it is solid, transparent, a cubic inch in size, cold to the touch, sitting motionless on the table, and so on. Those are the different ways that it actually is. But that would not be a full description, which would require noting also the ways it potentially could be. For example, potentially it is liquid if you melt it. Potentially it's flying through the air if you throw it. Potentially it is smaller if you break a piece off of it, and so on. A potentiality is not an actuality, but it is not nothing either. It is really there in the ice cube, even if not actualized. For example, if you keep the ice cube in a freezer for 10 years and it never in fact melts, it still has the potential to melt in a way that it does not have the potential to turn into gasoline or to grow legs or to solve equations. So Aristotle would say that while Parmenides is correct to hold that being cannot arise from non-being, his error is to suppose that that is what change would involve. What change really involves, for Aristotle, it's not going from non-being or nothingness to being. What it really involves is rather one kind of being or reality coming from another kind, namely being in actuality arising from being in potentiality, where potentiality is something real. It's not nothing, even though it's not actuality either. It's a kind of middle ground reality between actuality and nothingness. Or to speak a little more plainly, change involves the actualization of a potential. It is also wrong for Parmenides to characterize the space between objects as nothingness or non-being, because it has potentialities, and potentialities are not nothing. Once we identify potentiality as a kind of reality distinct from actuality, Parmenides' arguments against change and against multiplicity collapse. Now, Zeno makes a similar error in Aristotle's view. While it is true that there's an infinite number of ever smaller distances between points A and B, these smaller distances are there only potentially rather than actually. Hence, there is not an actually infinite number of distances for a runner to traverse, and the dichotomy paradox falls apart. Similarly, the infinite number of parts in an object are there only potentially until we do something to divide it. Until we divide it, there is in actuality just the one object. The parts are in it, but only potentially rather than actually. They're not nothing. They really are there, but they're not actual. They're merely potential. Hence, the paradoxical consequences of an object having an actually infinite number of parts are blocked. The error of Parmenides and Zeno is essentially to collapse all reality into actuality, ignoring potentiality. Now, Heraclitus makes the opposite error, in effect, of collapsing all reality into potentiality and denying actuality. For he holds that there is only endless becoming, change that is not changed to anything, that never congeals into anything determinate. In effect, he posits a world of potentialities which only ever give way to other potentialities without any of them being actualized. But this cannot be. For potentialities, though distinct from actualities, are in Aristotle's view always grounded in actualities. For example, it is because the ice actually has the unique chemical structure that it does that it has the potentiality to melt when the temperature drops below 32 degrees Fahrenheit. If it had some other chemical structure, it would have had a different melting point. Okay. So, we'll come back to some of these issues, but for the moment, let's see at last how all of this gives rise to hylomorphism. And so this was background to hylomorphism, and now we turn to the largest section of my talk here, which is what I've got labeled there on the handout as key aspects of hylomorphism. As scholastic followers of Aristotle, like Thomas Aquinas, point out, the distinction between actuality and potentiality is completely general, applying to all possible kinds of substance. For example, suppose there are angelic intellects, which would be minds that exist apart from matter. And as Thomas mentions, I guess the next talk in the series will be on that. Now, whether there are angels or not, I mean, obviously that's a matter of controversy. But here I'm just appealing to the idea by way of example, by way of illustration. So, supposing there are minds without matter or angelic intellects, they would have to go from potentiality to actuality when created by God. So the notion of actuality and potentiality is entirely general, applies even beyond the material world, if there is anything beyond the material world, though that's not our focus here in this talk. But the notions of potentiality and actuality apply in a special way to physical things in Aristotle's philosophy and that of Aquinas and other followers of Aristotle. Apply to the objects of perceptual experience, things we can see, hear, taste, touch, and smell. Unlike angelic intellects, physical objects are susceptible of both generation and corruption, of coming into being and going out of existence. And they occupy specific locations in space and time. What makes this possible is that they are composites of potentiality and actuality of special kinds, namely matter and form, in Aristotle's specific understanding of those terms, which I'm going to talk about. And where the Greek words for matter and form, hule and morphe, give us the word hylomorphism. So hylomorphism basically means matter-formism, as it were. Okay. Now, in change, there is again both a potential that is to be actualized and the actualization of that potential. Consider the ink in a dry erase marker of the kind I might use on this marker board, say. While still in the pen, it is actually liquid. Like, why don't I grab a pen? Now I'd make the lecture just a little bit more exciting with a prop. Okay, so now I've added concreteness to all these dry abstractions. Okay, well, I gave it a shot anyway. Okay, so consider the ink in a dry erase marker. While still in the pen, it is actually liquid, but it has the potential to dry into a triangular shape on the surface of a marker board. When you use the pen to draw a triangle on the board, that potential is actualized. Having dried into that shape, the ink has yet other potentials, such as the potential to be removed from the board by an eraser and in the process to take on the form of dust particles. When you erase the triangle and the dried particles of ink fall from the board and or get stuck in the eraser, those potentials are actualized. Now, what we have in this scenario is, first of all, what you might call a determinable substratum that underlies the potentialities in question, namely the ink. We also have a series of determining patterns that substratum takes on as the various potentials are actualized. Patterns like being liquid, being dry, being triangular, and being particle-like. The determinable substratum of potentiality is what in hylomorphism is meant by the term matter. That's just what matter means, as Aristotle uses it, this determinable underlying substratum of change. And it also has a determining pattern that exists once the potential is actualized, and that's what's meant by form, Aristotle's technical notion of form. Matter is essentially, as Aristotle understands it, that which needs actualizing in change. And form is essentially that which results from the actualization. Now note that any determining actualizing pattern counts as a form in this sense. A form is not merely the shape of a thing, nor is it necessarily a spatial configuration of parts, though shape and spatial configuration are kinds of forms. They're not the only kinds. Being blue, being hot, being soft, etc., would also be forms in the relevant sense, in the sense in which Aristotle understands that term. Okay, and there I've summarized one of two main lines of argument that Aristotelians often give for hylomorphism, which you can call the argument from change. We'll come back to this. There's another sort of consideration often given in defense of it, though. Change is not the only phenomenon that points to the distinction between matter and form. Note that a form or pattern, like triangularity, is universal rather than particular. It is the same pattern that one finds in green triangles and red ones, triangles drawn in ink and those drawn in pencil, triangles used as dinner bells and those used on a billiards table, and so forth. Triangularity is also perfect or exact rather than approximate. For example, being triangular in the strict sense involves having sides that are straight rather than wavy. Now, the triangle you draw on the marker board has straight sides, but only imperfectly or approximately. It is also a particular instance of triangularity rather than triangularity as such. Triangularity is a universal pattern. Hence, there must not only be something by virtue of which the thing that you've drawn is triangular, but also something by virtue of which it is triangular in precisely the imperfect way that it is. And there must also be something by virtue of which triangularity exists in this particular point in space, this particular point in time. Now, if being triangular is a way of being actual, then being triangular only in an imperfect way is a way of being potential. For insofar as the triangle's sides are only imperfectly straight, the ink in which you've drawn it has, you might say, only partially actualized its potential for triangularity. And insofar as the triangle has been drawn in some particular time and place, here rather than there, now rather than then, the potential in question is a potential at that time and place rather than at another that has been actualized. Now, that by virtue of which what you've drawn is actually triangular to the extent that it is what Aristotle again means by its form. While that by virtue of which it is limited or remains merely potential, in the extent to which it is triangular is its matter. Matter plays the role of tying this universal pattern down to this particular point in time and space, and what accounts for the fact that it's only an approximation of this more perfect universal pattern of triangularity. So this is a second consideration often given in favor of hylomorphism, which is sometimes called the argument from limitation. Matter is that what limits or ties a universal form or pattern down to a particular point in time and space, and what limits its being a perfect manifestation of triangularity, say, or any other form or pattern. Now, insofar as form accounts for whatever permanence, unity, and actuality that there is in the natural world, it represents, as it were, the Parmenidean side of things, the static monist side of things, the Zeno side of things. The triangle drawn on the marker board persists to the extent that it retains its triangular form, is identical to other triangles, or united to them, or exhibits kind of unity, insofar as it is an instance of the same one form that they instantiate, and is perfect or complete in its actuality to the degree that it approximates that form. So form is, you might say, the Parmenides-Zeno aspect of reality, the stability aspect of reality. Insofar as matter accounts for the changeability, the diversity, and potentiality that exists in the natural world, it represents the Heraclitean side of reality. The triangle drawn on the board is impermanent insofar as its matter can lose its triangular form, is distinct from other things having the same form insofar as it is one parcel of matter among others which instantiate it, and is imperfect or potential to the extent that it merely approximates the form. Okay, so matter, you might say, is the Heraclitus side of reality. Without form, we would have a purely Heraclitean type world, the world in constant flux, never actualizing into anything, one potential constantly giving way to another. Without matter, we would essentially have a Parmenides Zeno type world, a completely static and unchanging world. So Aristotle's saying, well, if neither of those extremes can be correct, then we have to acknowledge the sober but boring truth of both form and matter as being equally fundamental aspects or constituents of physical reality, of perceptible reality. It's the only way to account for the fact that the world is neither really Parmenidean nor Heraclitean. Okay. Now, matter you can think of as passive and indeterminate, form active and determining. The same bit of matter can take on different forms, and the same form can be received in different bits of matter. Hence, matter and form are as distinct as potentiality and actuality. Still, just as potentiality is grounded in actuality, so too does matter always have some form or other. If the ink in our example is not in a liquid form, then it is in a dry, triangular form. And if not in that, then in the form of particles. And if the particles are broken down further so that the ink is in no sense still present, then the form of the chemical constituents of the ink would remain. If matter lacked all form, it would be nothing but the pure potentiality for receiving form. And if it were purely potential, there would be no actuality to ground it, and it would not exist at all. So we can distinguish form and matter, but matter always exists in some form or other, even though the form is distinct from the matter that has the form. Now, several further distinctions are needed in order to flesh out the hylomorphic analysis of what it is to be a physical substance. And I know you were worried for a minute, there's not enough technical jargon in this talk. Could you throw a little more in? I want to please my audience, so I'm going to throw a little more in. And you see some of these distinctions here at the bottom of page 1 of the handout. First, there is the general distinction between any substance and its attributes. This is a traditional metaphysical distinction. A substance and the attributes, or sometimes called the accidents that the substance has. So consider a solid, gray, round, smooth stone of the sort you might pluck from a riverbed and throw at a boring lecturer. Never. The solidity, grayness, roundness, and smoothness are attributes of the stone, and the stone itself is the substance which bears these attributes. The attributes exist in the stone, whereas the stone does not exist in any other thing in the same sense. Substances in general are just the sorts of things which exist in themselves, rather than inhering in anything else, which are the subjects of the attributes which do of their nature inhere in something else. So you could throw a stone through the window, you could throw the stone at the lecturer, but you can't think, that's a little violent, I'll just throw the color of the stone at the lecturer, right? Well, color has no independent status. It exists only in the stone. The shape of the stone exists only in the stone. But the stone itself doesn't exist in another thing in the same way. The stone, in that sense, you could think of as a substance. It stands under or below the attributes and kind of holds them together. Okay, this is true of physical or corporeal substances like stones, and it's also true of incorporeal substances too, if there are any such things. If there are immaterial souls or angels or what have you, they would be substances with attributes as well. So this is another completely general distinction, though we're interested in its application to physical objects. Okay, so physical substances specifically are, again, composed of form and matter. But here, 2 further distinctions must be made. If we abstract from our notion of matter all form, leaving nothing but what I have called the pure potentiality to receive form, we arrive at the idea of prime matter. Prime matter, that's the idea of the purely material side of a physical object, the purely potential side of it. That which is waiting, as it were, to receive form. Let me say more about that in a moment. Matter already having some form or other, that is to say, matter which actually is a stone or wood or water or what have you, and is not merely potentially any of these things, is secondary matter. Okay, prime matter and secondary matter. This is the traditional Aristotelian distinction. Now, there's a corresponding distinction between kinds of form. A form which makes of what would otherwise be utterly indeterminate prime matter some determinate concrete thing of a certain kind, what makes it not just potentially a thing, but actually a thing of this particular sort, is what's called substantial form. It's the form that makes matter into a substance, an actual substance. a form which instead merely modifies some secondary matter, modifies something that's already a kind of substance, because it's already got a substantial form, that would be what's called an accidental form. Stated more precisely, then, the basic claim of hylomorphism is that any physical substance is a composite of prime matter and substantial form, of a purely potential substratum and a kind of form that makes it into a substance of a specific kind. A water molecule, a dog, a stone, whatever it might be. Okay. Now, the distinction between substantial form and accidental form is illuminated by comparison with the different but related Aristotelian distinction between nature and art, between natural kinds and mere human artifacts, human inventions. That is to say, well, I already said that. So take, for example, a liana vine. A liana vine is the kind of vine that Tarzan likes to swing on in the stories. And take that to be an example of a natural object. Whereas a hammock that Tarzan might construct from living liana vines would be a kind of artifact and not a natural object. The parts of the liana vine have an inherent tendency to function together to allow the vine to exhibit the growth patterns that it does, to take in water and nutrients, and so on. By contrast, the parts of the hammock, the liana vines themselves, have no inherent tendency to function together as a hammock. Rather, they must be arranged by Tarzan to do so and left to their own devices, that is to say, without pruning and occasional rearrangement and the like, they will tend to grow the way they otherwise would have had Tarzan not interfered with them, including ways that will impede their performance of a hammock. Their natural tendency, you might say, is to be liana-like and not to be hammock-like. The hammock-like function they perform after Tarzan ties them together is extrinsic or imposed from outside, while the liana-like functions are intrinsic to them or built into them. Now, the difference between that which has such an intrinsic or built-in principle of operation, like the liana vine, and that which does not, but only has an externally imposed function, like a hammock that you make out of liana vines, that's essentially the difference between something having a substantial form and something having merely an accidental form. That's one way to think about it. So what has a substantial form, like the liana vine, has a built-in tendency towards certain operations and activities, growing a certain way, taking in water, what have you. Whereas the hammock has only an accidental form. Its parts are substances, vines, whose built-in tendency is to function like vines. And function like a hammock is something that's to be imposed from outside by Tarzan coming along and tying them together in a certain way, say. So being a liana vine involves having a substantial form, while being a hammock of the sort we're discussing involves instead the imposition of an accidental form on components, each of which already has a substantial form. Again, namely the substantial form of a liana vine. A liana vine is accordingly a true substance, as Aristotelian hylomorphism understands substance. A hammock is not a true substance precisely because it does not, qua hammock, have a substantial form. It doesn't have an intrinsic or built-in principle by which it operates as it characteristically does, but only an accidental form. In general, true substances are typically natural objects, whereas artifacts are typically not true substances. A dog, a tree, and water would be true substances on this account because each has a substantial form or intrinsic or built-in principle by which it behaves in the characteristic ways that it does. But a watch, a bed, or a computer would not be true substances because each behaves in the characteristic ways that it does only insofar as certain accidental forms have been imposed on them from outside by us. The true substances in these cases would be the raw materials, metal, wood, glass, etc., out of which these artifacts are made. It's important to emphasize, however, that the correlation between what occurs in the wild and what has a substantial form on the one hand, and on the other hand, the correlation between what is man-made and has only an accidental form are only rough correlations. For there are objects that occur in nature and apart from any human intervention, and yet have only accidental forms rather than substantial forms, such as a pile of stones, say, that gradually form at the bottom of a hill, and beaver dams, say. Though they're not built by human beings, they would be considered by Aristotle, say, to be, in effect, artifacts or having only accidental forms rather than being true substances. And then by the same token, there are man-made objects that have substantial forms rather than accidental forms, and so would count as true substances, such as water synthesized in a lab, or breeds of dog, or babies. And babies are natural objects. They're not mere artifacts. even though they're obviously, in a sense, made by human beings. Okay, now, of course, no one will be tempted in the first place to think of these as artifacts in the same sense in which watches and computers are artifacts. But even objects that are artificial in the sense that they not only never occur in the wild, but require significant scientific knowledge and technological expertise to produce, can count as having substantial forms rather than accidental forms. Styrofoam would be one possible example that contemporary Aristotelians have suggested. Now, the basic idea, and here we're at the bottom there, part 4, marks of substantial form, 4b here. The basic idea here is that it seems to be essential to a thing's having a substantial form that it has properties and causal powers that are irreducible to those of its parts. Hence, water has properties and causal powers that hydrogen and oxygen, considered by themselves, do not have, whereas the properties and causal powers of, say, an axe seem to amount to nothing over and above the sum of the properties and powers of the axe's wood and metal parts. An axe is just the sum of the parts, whereas water, it's the sum of just the wood and the metal of the axe combined, whereas water is not just the sum of, say, putting 2 parcels of oxygen and hydrogen next to one another. Okay, so when water is synthesized out of hydrogen and oxygen, what happens is that the prime matter underlying the hydrogen and oxygen loses the substantial forms of hydrogen and oxygen and takes on a new substantial form, namely that of water. That's what the Aristotelian would say anyway. By contrast, when an axe is made out of wood and metal, the matter underlying the wood and the matter underlying the metal do not lose their substantial forms. Rather, while maintaining their substantial forms, they're still wood and metal, they take on a new accidental form, that of being an axe. The making of styrofoam seems to be more like the synthesis of water out of hydrogen and oxygen than it is like the making of an axe. Styrofoam has properties and powers which are irreducible to those of the materials out of which it's made, the chemical constituents out of which it's made, which indicates the presence of a substantial form and thus a true substance. Now, there's a further complication to the story. For among the attributes of a thing, we need to distinguish those that are proper to it from those that are not. It is the former alone which are labeled properties in Aristotelian Thomistic philosophy, with the others referred to as contingent attributes. And this contrasts with the very loose way in which the term property is used in contemporary analytic philosophy to refer to more or less any feature that we might predicate of a thing. The properties or proper attributes of a substance are those which flow or follow from its having the substantial form that it does. For example, being four-legged flows or follows from having the substantial form of a dog. It is a natural concomitant of dogness, as it were, as such, whereas being white, say, is not, but merely a contingent attribute of any particular dog. So the idea is that any dog in its mature and fully healthy state, an undamaged state, it's going to have 4 legs, say. So that would be a property or proper attribute of a dog. Whereas a dog can be fully mature and healthy and be white or brown or black or what have you. So color is not a proper accent, it's a contingent one. The dog may or may not have it and still be a fully functioning dog. Okay. Now, this flow can, as it were, be blocked. The way that the proper attributes of a dog follow from its nature or substantial form can be blocked. For example, a particular dog might, as a result of injury or genetic defect, be missing a leg. But it wouldn't follow from its missing that leg that being four-legged is not, after all, a true property of dogs. Nor would it follow that this particular creature was not really a dog after all. Rather, it would be a damaged or defective instance of a dog. When determining the characteristic properties and causal powers of some kind of thing, then, we need to consider the paradigm case, what that kind of thing is like when it is in its mature and normal state. So, a thing counts as a true substance when it has a substantial form rather than a merely accidental form, and the mark of its having, the former, is that in its mature and normal state, it exhibits certain properties and causal powers that are irreducible to those of its parts. Aquinas' interpretation of Aristotle's hylomorphism insists further on what's called the doctrine of the unicity of substantial form, according to which a substance has only a single substantial form. Okay, so here we're at the bottom of page 1. So suppose some object A is a substance and it has B and C as parts, whatever A, B, and C are. A could be water, and B and C could be hydrogen and oxygen, say. Okay, so suppose A is a substance and has B and C as parts. Since A is a substance, it has a substantial form. Do B and C have further substantial forms of their own? Well, if they did, then they too would be substances. In that case, though, A's form would relate to B and C as an accidental form relates to secondary matter. But in that case, A wouldn't really have a substantial form after all, and thus it wouldn't really be a substance. It would be something more like an artifact. So if A really is a substance, then its parts B and C must not themselves have substantial forms or amount to true substances in their own right. There is only the single substantial form, the form of A, which informs the prime matter of A, the form of water, say, in our example. Another way to look at it is that if B and C, the hydrogen and oxygen, say in my example, had substantial forms, then they would be what actualizes the prime matter so that it constitutes a substance, or two substances in this case, namely B and C. In that case, the prime matter wouldn't potentially be a substance, like water, but would already actually be a substance, or two substances, hydrogen and oxygen. That is to say, it would be secondary matter rather than prime matter. But then there would be nothing left for the substantial form of A to do qua actualizer of prime matter. It would serve merely to modify an already existing substance and thus amount to an accidental form rather than a substantial form. And so again, for thinkers like Aquinas, any substance A can really only have one substantial form. This is again the idea of the unicity of substantial form. Now, to see the implications of this, consider once again our example of water, which has hydrogen and oxygen as its parts. Suppose, for the sake of argument, that water is a true substance rather than an aggregate of particles, say an aggregate of parts, and suppose then that it has a substantial form. Since a substance can only have a single substantial form, it follows that the hydrogen and oxygen in water don't have substantial forms. There's only one substantial form, that of the water as a whole. But that entails in turn that hydrogen and oxygen themselves don't exist in the water as substances. I didn't say they don't exist in the water, but not as substances. Now this may seem odd since hydrogen considered by itself and oxygen considered by itself each do seem to be substances. They have their own characteristic irreducible properties and causal powers after all. But the lesson we should draw from these considerations, according to Aquinas' doctrine of the unicity of substantial form, is that hydrogen and oxygen do not exist actually in water, but only virtually. Now notice that the claim is not that they don't exist in water at all. I'm not saying that. It is rather that they don't exist in water in the way that they exist when they exist on their own. The situation is comparable to the Aristotelian account of what is really going on in Zeno's paradox of parts, in which the parts are present, they're not nothing or non-being, but they're only there potentially rather than actually. Remember, Aristotle says potentiality, it's a kind of a reality. It's not nothingness, but it's not actuality either. So in the same way, for Aristotelians like Aquinas, hydrogen and oxygen say, and this is my example, not his, but I'm using it to illustrate his idea. He would say hydrogen and oxygen are really there in water. He's not denying that fact of modern chemistry, but he's saying their status corresponds more to potentiality, or what he would call virtual reality in the water rather than actually. What's actually there is water. And hydrogen and oxygen are there virtually in the sense they can be drawn out of water in the way that other substances could not be drawn out of water. Okay, so this is taken to be an implication of the idea of what's called the unicity of substantial form. Now, this too may sound odd, but it should sound less so upon reflection. For consider that if hydrogen and oxygen were actually present in the water, in just the way they are when they're separated out, say, then they should possess their characteristic properties and powers. You should have things containing the characteristic properties and powers of hydrogen and the characteristic properties and powers of oxygen. That means, for example, that we should be able to burn the hydrogen and to boil the oxygen at minus 183 degrees Celsius. But in fact, we can't do either. Hence, the substantial forms of hydrogen and oxygen can't be present, in which case the substances, hydrogen and oxygen, cannot be present either, given the hylomorphic analysis. Furthermore, if hydrogen and oxygen were actually present, and not merely virtually present, then for something to be water would be for it to have a merely accidental form, like being a hammock is just an accidental form of the vines that you tie together. And properties and causal powers, its properties and causal powers would be reducible to those of hydrogen and oxygen, like the powers of the axe are reducible to those of the wood and metal that makes up the axe. But that is also not the case, since water has powers and properties that a mere aggregate of hydrogen and oxygen do not. Hydrogen and oxygen are present in water then in the sense that water has the potentiality to have hydrogen and oxygen drawn out of it by electrolysis, say. Now, as I've indicated, two of the motivations for hylomorphism have to do with its application to the critique of static monism's denial of multiplicity and change, Parmenides and Zeno's denial of multiplicity and change. These lines of argument for hylomorphism are sometimes labeled the argument from limitation and the argument from change, as I noted earlier. The basic idea of the first line of argument is, again, that a form is of itself universal, so that we need a principle to explain how it gets tied down, as it were, to a particular thing, time, and place. For example, roundness can be instantiated in multiple objects. Different objects can be round, can exhibit that property of roundness. And it can be exhibited at different times and at different spatial locations. And the geometrical truths pertaining to it remain true whether or not any particular round thing or group of round things comes into existence or remains in existence. Roundness is thus not as such limited, so that something needs to be added to it if we do in fact find it limited in some way, in some particular time and place. Matter, the matter of this individual bowling ball, of that individual wheel, that individual pie pan, and so forth, is what does this job. It's what ties this universal pattern of roundness down to this or that particular time and place. For example, it's the matter of some individual wheel that accounts for the fact that roundness is instantiated in some particular automobile in a way that it's not instantiated in, say, the tree next to the automobile or in the road under the automobile. Matter also accounts for limitation in another respect. The roundness of a circle is defined in geometry as defined in geometry is perfect or exact, yet any particular round object drawn on a chalkboard or in a book or what have you is always at least to some extent imperfect. Matter accounts for this kind of limitation too, insofar as qua the potentiality to receive form, it is never fixed or locked onto any one particular form, but is always ready to take on another. Okay. That, again, is the basic idea of what I call the argument from limitation for the reality of form and matter. For the moment, however, and this brings us to the top of page 2, is the argument from change about which more must be said. On an Aristotelian analysis, a real change involves the gain or loss of some attribute, but also the persistence of that which gains or loses the attribute. For example, when a banana goes from being green to being yellow, the greenness is lost and yellowness is gained, but the banana itself persists. It's the same banana at the end of the process that existed at the beginning. If there were no such persistence, we would not have a change to the banana, but rather the annihilation of a green banana and the creation of a new yellow one in its place. That's not, in fact, what happens. Matter for hylomorphism essentially just is that which not only limits form to a particular thing, time, and place, but also is that which persists when an attribute is gained or lost. That's another job that matter, as understood in hylomorphism, does. It's what stays the same throughout change. It is absolutely crucial to understand that the characteristics of matter identified so far, for example, its correspondence to potentiality as contrasted with forms corresponding to actuality, or its status as the principle of the limitation of form, and its status as the principle of persistence through change, these are definitive of matter as hylomorphism understands it. That is to say, the hylomorphist is using the term matter in a technical sense. He's not saying that matter, as it has independently come to be understood by modern physics and chemistry, is what turns out to be the stuff that plays the role of persisting through change, limiting form, and corresponding to potentiality. Hylomorphism is not so far saying anything about matter in the modern sense at all. So if you think, well, all that stuff about limitation, change, act, potency, I don't remember reading about that in the physics textbook, right? Well, hylomorphism is using the term matter in a specific sense. Matter just means that which does those jobs. How does that relate to the physicist's conception of matter? Well, I'm going to come back to that. But the term is being used in a technical sense. That's the point I'm trying to make for the moment. Okay. Rather, hylomorphism is defining matter then as that which plays these roles. Nor is this some eccentric usage. You might think, what an odd usage. Where did they come up with this, right? Well, actually, this is how the term matter was originally used. This is the term that goes back to the ancient Greeks, to Aristotle in particular. So it's a usage that's older than that familiar from modern physics and chemistry. Now, of course, how matter in this technical sense, this hylomorphic Aristotelian sense, relates to matter in the modern sense is a good question, and one that I'll be addressing presently. Point for the moment, again, is simply to forestall irrelevant objections and misunderstandings, to note exactly how Aristotle and his followers are using this term. Now, one sort of change that takes place is change to a persisting substance. The subject of this sort of change is what the Aristotelian calls secondary matter, matter already having some substantial form or other. For the Aristotelian, we can identify three kinds of change that fall into this class. There is, first of all, qualitative change, as when the banana in our example changes color from green to yellow. Second, we have what's called quantitative change, as when the banana, having begun to rot, shrinks in size, shrivels. And third, there is local motion or change with respect to location or place, as when the banana flies through the air when you toss it toward the wastebasket, or again toward the lecturer, if you're growing even more impatient here. Okay. Not as much laughter. It's like, no, we really aren't thinking that. Okay. Another more radical, he said, how can he read minds, right? I thought he was a philosophy lecturer. Another more radical, I can read faces, that's for, okay. Another more radical kind of change is change of a substance, or what's called substantial change. It is change that involves not a substance gaining or losing some attribute while still persisting, but rather a substance going out of existence altogether and being replaced by a new one. This is what happens when the banana is eaten, digested, and incorporated into the flesh of the animal that ate it. Or when it is burned and reduced to ash. You throw it into the fireplace, say, and it's reduced to ash over time. Because change requires some underlying persisting subject that does not change, there must be such a subject in the case of substantial change, of this more radical sort, no less than in the case of the other kinds. That because it is the very substance itself that goes out of existence in this case, it is a substantial form that is lost, not merely an accidental form. Hence, it is not any kind of secondary matter that is this sort of that is the subject of this sort of change, but rather what we referred to earlier as prime matter, the pure potentiality to take on form, or to lose form for that matter. Now, since prime matter is that which underlies the loss of one substantial form and the gain of another, it does not of itself have a substantial form, and is therefore not of itself any kind of substance. Nor, since the having of accidental forms and attributes in general presupposes being a substance, does it possess any attributes or accidental forms either. It is not actually anything of a specific kind at all. But that does not entail that it is nothing. For remember that between actuality and nothingness or non-being, there is this middle ground of potentiality, which is a kind of being. That is what prime matter is, the pure potentiality to receive form. Okay. You might say, that's a pretty weird idea. Prime matter is a pretty weird idea. I submit it's no weirder than quantum mechanics. In fact, it's very closely related. I'm going to come back to that. Now, because potentiality cannot exist without actuality, prime matter does not exist without actuality. That is to say, it does not exist on its own, in a free state, you might say, but only together with some substantial form or other. All matter as it exists in reality, outside the mind, is secondary matter, matter having some form or other. But that does not entail either that prime matter is not real, or that it is not really distinct from the substantial forms with which it is conjoined. Being trilateral, having three straight sides, is a different geometrical feature from being triangular, having three angles, even though a closed plane figure cannot have the one without also having the other. We can distinguish them in thought, and what we thereby distinguish are features that are different in reality, even if outside the mind, the one cannot be separated from the other. And in the same way, prime matter and substantial form differ in reality, even if they too cannot be separated in reality, but only in thought. Without prime matter, there would be no substantial change because there would be no subject of change that persists through the change. There would be nothing that continues the same through a substantial change, like throwing the banana and reducing it into the fire and reducing it to ash, say. It would rather be the complete annihilation of one substance and the creation of another, utterly novel substance in its place. That the world does not, in fact, work like that is evident from the continuity that substantial change, no less than the other sorts of change, actually exhibits. For example, wood that is burned reliably turns to ash and not to water or to cheese or to rose petals. Why would this be the case if there were absolutely nothing that carries over from the wood to the ash, but rather the complete disappearance of the first and the appearance out of nothing of the second? Why wouldn't just any old thing appear in place of the wood? And the Aristotelian would answer, well, we need prime matter then as the substratum of this more radical kind of change of one substance to another. Okay, thus spake Aristotle and Aquinas. Okay, so let's move on then to stage 4 here on page 2 and turn to this alternative position, having given this fairly detailed exposition of hylomorphism, this conception of matter that Aristotle develops in the ancient world and then dominates medieval science and philosophy up to the early modern period. It's replaced by what's variously called the mechanical world picture, the mechanical philosophy. So let me say a bit about that. Mechanical philosophy is a generic label for a set of views about the nature of matter that began to supplant hylomorphism in the thinking of philosophers and scientists in the 17th century. Now, the paradigmatic version of the mechanical philosophy is atomism, first developed by ancient Greek philosophers like Democritus and revived by early moderns like Pierre Gassendi and Thomas Hobbes. Atomism, as it was originally understood, holds that all observable physical objects can be broken down into unobservable particles, which cannot in principle be broken down further. The idea of such an indivisible particle being the original meaning of the word atom, which has obviously in modern science come to have a different sense. So the original idea of an atom was, well, an atom is the bottom level. It cannot be broken. That's what atom literally means, unsplittable, unbreakable. So splitting the atom would sound paradoxical to an ancient Greek atomist. That's because the term atom has lost that original meaning. Okay. Differences between observable objects, according to atomism, are just differences in the configurations of the atoms. And all changes to an object and changes of one object into another can be accounted for in terms of changes in the configurations of atoms as they move through space. Being indivisible or unbreakable, the atoms on this view are the unchanging substrate of all change. Okay, that you might say is mechanical philosophy 1.0, right? That was the original idea. And then it ends up being modified in various ways by different early modern philosophers and scientists. So other versions of the mechanical philosophy have different conceptions of the particles. For example, Descartes thought that no particle could be indivisible in principle, so that there is no bottom level of particles. It's particles all the way down ad infinitum for Descartes. By contrast, the corpuscularianism, that's a great word, corpuscularianism, right, of Robert Boyle and John Locke, they instead agree that all particles are divisible in principle, but they nevertheless posit a bottom level of particles that just happen to be undivided in fact. So it's kind of middle ground position between atomism of the old sort and Descartes. The corpuscularians, Robert Boyle, John Locke, they say, yeah, you're right, Descartes, all matter is divisible ad infinitum in principle. There are no atoms in the sense Democritus thought there were. Nevertheless, there's a bottom level of particles that just simply happens not to be divided further. Call those corpuscles. Okay, so that's another variation. Yet another is what was called the force shell atom theory of Roger Boscovich, which takes the particles to be unextended, like unextended points, unextended and thus indivisible points that project shells of force. And there are yet other differences between these variations, such as their divergent accounts of the nature of space. Some of them conceive of space as a void, some of them don't. But what they all have in common is the idea that all observable objects are really just aggregates of particles whose properties and powers can be reduced to the sum of those of the particles themselves, in something like the way that a machine is an aggregate of parts whose properties and powers can be reduced to the sum of the properties and powers of the parts. And that's the reason for the mechanical philosophy label, the idea of the world as a kind of machine. That everything in the world is really what Aristotle would think of as an artifact rather than a true substance. It's an aggregate of parts. And you can understand the whole by breaking it down to its parts and understand how the parts relate to one another as they move through space and connect together, break apart. That's the basic idea of a mechanical model of physical reality. So as I say, in other words, the view essentially treats ordinary natural objects as having what hylomorphism would call accidental forms rather than substantial forms. It also treats all the parts out of which they are composed, including the ultimate parts, as actual rather than merely potential, rather than merely virtual. So for the mechanical philosophy, all the parts of a whole are really there actually, not merely virtually as they are for Aquinas and other medieval hylomorphists say. So once again, to refer to our water example, the mechanical philosophy would say that oxygen and hydrogen are actually, rather than merely virtually, in water, and that its ultimate constituents are actual particles of some sort, rather whatever the bottom level turns out to be, rather than the pure potentiality of prime matter. All of this distinguishes this view not only from hylomorphism, but also from Heraclitus's dynamic monism, since it takes the ultimate particles to be discrete and unchanging unities. And Heraclitus says there are no discrete and unchanging unities. And it also differs from the static monism of Parmenides and Zeno, since the mechanical philosophy affirms that the particles are distinct objects and that they really do change as they move through space. So it's not Aristotle, it's not Parmenides, it's not Heraclitus. It's its own kind of view. Now, mechanical philosophy would take Feynman's description of evaporation, which I quoted earlier, to be a paradigmatic illustration and indeed vindication of the mechanical philosophy's mode of explanation. You break water down into its particles, and by understanding how the particles relate to one another as they move through space, you essentially have all the explanation you would want. So the mechanical philosophy would say, that passage that I read from Feynman, that's a gold standard vindication of a mechanical view of how the physical world works. Now, the average educated person may even agree and suppose that the mechanical philosophy has been confirmed thereby by modern science. But nothing could be further from the truth, or so I would argue. In fact, the mechanical philosophy's conception of matter faces a number of grave problems. And for present purposes, I will discuss 5 of them. Okay, we're in the home stretch now, right? We're building up to quantum mechanics here. So this brings us to the middle there of page 2. The first of these problems is what we might call the reductionism problem. Because the mechanical philosophy treats ordinary physical objects as having accidental rather than substantial forms, it entails that dogs, trees, stones, and the like are not really substances. The true substances are the fundamental particles, and to be a dog, a tree, or a stone is just for these particles to take on a certain kind of accidental form. A dog, a tree, or a stone is entirely reducible to the sum of the particles of which it's made. Just like a hammock is reducible to the sum of the liana vines and the knots into which they're tied. Or just like an axe is reducible to the sum of what you get when you take a wooden stick and you stick this metal object on top of it. And there's nothing more to it than that. It's reducible to the sum of its parts. Okay. Now the problem is that it turns out to be extremely difficult at best, and indeed probably most today would say impossible in principle, entirely to describe a dog, for example, in terms of nothing more than the particles that make it up and their properties, their individual properties and powers. Dogs and the like simply have properties and causal powers that are irreducible to the sum of those of their parts. Now, many philosophers who acknowledge this opt for a position they call non-reductive physicalism. The trouble with this, I would argue, is that this sort of view on analysis turns out to be ambiguous between hylomorphism and mechanical philosophy-style reductionism. As I've said, the irreducibility of a thing's properties and causal powers to those of its parts is, for hylomorphism, a mark of the presence of a substantial form rather than merely an accidental form. The non-reductive physicalist doesn't want to go so far as to revive the notion of substantial form and all that other Aristotelian stuff, and wants to treat the parts of a substance as actually rather than merely virtually in the substance. But this, the hylomorphist argues, implicitly entails reductionism after all. For either it directly treats an object as having only an accidental form, and thus not really a true substance, or it indirectly does so by virtue of denying the unicity of substantial form. So, what in the work of contemporary philosophers is called non-reductive physicalism or non-reductive naturalism, the idea that, well, physical objects are essentially nothing more than aggregates of their component parts, even if they have properties and powers that can't be reduced to the sum of those parts. That, I'm saying, is really an unstable middle ground position. On analysis, it either collapses back into mechanical philosophy reductionism, or it really collapses back into Aristotle's hylomorphism. It ends up being a more old-fashioned view than its defenders realize. Okay, so call that the reductionism problem for the mechanical philosophy. A second and related problem for the mechanical philosophy is what we might call the identification problem. If we say that a dog or a stone is really just a collection of particles, then we have to ask exactly which collection of particles that is. For example, does the collection of particles that make up a stone include those particles that are floating in the air 2 inches out from the surface of the stone? Does it include only those particles that exist half an inch or deeper below the surface of the stone? Presumably the answer in each case is no. But then it seems that we can identify the relevant particles that make up the stone only by reference to the stone of which they're parts. We can identify the parts only relative to the whole. We can't pick out the relevant particles except by reference to the stone as a whole, whereas the whole point of the mechanical philosophy was to try to show how there is nothing more to the whole than the parts, than the particles out of which it's composed. In this way, too, it turns out to be extremely difficult or impossible to reduce physical objects to collections of particles. The whole idea is to say the whole is nothing more than the particles out of which it's composed. And yet, we can't identify the relevant particles that make up the whole except by reference to that whole. They're not intelligible apart from the whole. Okay, so we'll call that the identification problem for a mechanical philosophy view of matter. A third problem is that from the point of view of hylomorphism, the atomist doesn't really get rid of substantial form and prime matter at all, but simply relocates them. Call this the relocation problem. Suppose that to be a dog or a tree or a stone really is to have a merely accidental form. It's like being a kind of artifact, like the hammock or the axe. Okay, and that the only true substances are the fundamental particles, the atoms, say, or whatever they turn out to be, the corpuscles or whatever. Well, we would still have to regard them as composites of substantial form and prime matter for the reasons given in the what I call the argument from change and the argument from limitation. For one thing, like any other form, the form of being a particle is universal. It's a universal pattern, and so there must be something that ties that form down to some individual thing, time, and place, to this particular individual particle at this particular time and place, to that particular particle at that time and place, and so on and so forth. And that's just what the job matter, in Aristotle's sense, does. And since the particles in question are fundamental rather than composites of something more fundamental, it's only prime matter that can do this job rather than any kind of secondary matter. And only this prime matter, together with the substantial form of a particle, would give us an actual substance. So you don't really get rid of the hylomorphic analysis in terms of substantial form and prime matter at all. You just relocate it to the bottom level, the level of fundamental particles. For another thing, as long as it is even in principle possible for a fundamental particle to come into existence or to go out of existence, there would have to be something that underlies this substantial change, which brings us back to prime matter and substantial form for the reasons I discussed a few minutes ago. Of course, the ancient atomists held that the fundamental particles could neither be generated nor corrupted, but merely to assert this does not make it so. It's hard to see how there could be such particles. Any particle is going to be limited in various ways, to being of this particular size and shape, for example, or to exist at this particular location at any moment, and so on. But what is limited in such ways is a mixture of actuality and potentiality rather than being pure actuality without potential. It is actually of this shape and merely potentially of some other shape. It's actually at this location and only potentially at some other location, and so on and so forth. Now, only what is pure actuality, something which has no potential that need to be or indeed could be actualized, but which is, as it were, always already actual, only what's like that could exist in an absolutely necessary way. It could be the sort of thing that never comes into being or passes away. And this idea of something that's purely actual and in no way potential is, in fact, the philosophical core of Aristotle and Aquinas' conception of God. It would be something divine. Anything less than that could exist only in a contingent way. But then the fundamental particles would have to be contingent rather than necessary, and thus the sorts of thing which could, in principle, either exist or not exist. This capacity either to exist or to fail to exist must have an underlying basis, which brings us back to the conclusion that the particles are composed of prime matter and substantial form. To be the sorts of thing that are neither generated nor corrupted, the particles basically have to be divine and have all the divine attributes. This gets us into other areas of Aristotle and Aquinas' philosophy. But since they're evidently not, then they must be the sorts of things that can come into being and pass away. And only what's made up of form and matter together could be like that. That's, in a nutshell, the argument. Okay, so that's what I call the relocation problem, that you don't really get rid of the ideas of substantial form and prime matter on the atomist view or any other mechanical philosophy view. You just relocate those notions, the applicability of those notions, to the bottom level, the level of the fundamental particles. Now, a fourth problem is posed by the mechanical philosophy's commitment to the thesis that all the parts of an object exist in it actually rather than virtually. For the parts in question are material parts that are extended in space. They've got extension, length, width, depth. And anything that's extended is in principle capable of being divided into smaller extended parts. Now, if extended parts are divisible into smaller extended parts ad infinitum, and if all the extended parts are actually, rather than merely potential, in the physical objects, then it follows that every such object will have an infinite number of parts. And in that case, the paradoxes identified by Zeno, which we described earlier, would follow. Every physical object, for example, would be infinitely large, and they would all be of the same size. So call this Zeno's problem. In other words, a mechanical conception of matter is susceptible of the very paradoxes of Zeno that Aristotle was trying to get us out of. Now, it's sometimes claimed that problems like this are really illusory on the grounds that infinite divisibility is merely an artifact of geometrical models. It does not apply to concrete physical reality. But as philosopher Thomas Holden points out in his book, The Architecture of Matter, this response really misses the point. The paradoxes arise not from the geometry alone, but from the geometry combined with the premise that the parts of an object are all actual rather than merely virtual or potential. They're all actually there rather than merely virtually there, the way Aristotle would say. That is why Aristotle can accept that a physical object is infinitely divisible without falling into Zeno's paradoxes. Because he doesn't deny the mathematics, but he rather simply rejects the assumption that the parts of an object are in it actually rather than merely virtually or potentially. And the mechanical philosophy opens itself back up to Zeno's paradoxes precisely by taking on board that assumption that the parts are there actually and not merely virtually or potentially. Okay, so that's what I call Zeno's problem for the mechanical philosophy. Okay, now we come to the last section here. And let us turn then finally to quantum mechanics, because that, I want to argue, poses a fifth problem for the mechanical philosophy, and arguably even vindicates hylomorphism, or at least gestures respectfully in its direction. To see how, recall first that hylomorphism takes prime matter on its own to be wholly indeterminate. By itself, it is not an actual particular physical thing of any kind, but rather the pure potentiality to be a particular physical thing of some kind. If we think of matter on the analogy of the position of a needle on a dial and the values on the dial as representing the various specific kinds of material thing that might exist, prime matter is like a needle that is flitting wildly across the face of the dial. It has no intrinsic or built-in tendency to stop at any particular value, though potentially it could be made to stop at any of them. It's ready to go in any direction, ready to be any sort of thing whatsoever. Substantial form is what actualizes that potential and makes of otherwise indeterminate prime matter a substance of some determinate kind, a molecule, a rock, a tree, a dog, or what have you. Now, if prime matter is like the needle flitting wildly across a dial's face, then for hylomorphism, a fundamental particle, considered in isolation and apart from any substance that it might partially constitute, is like a needle which has narrowed its flitting somewhat to a certain range of possible values. For example, fermions do not have the indeterminacy of prime matter, for they are matter of a certain kind, with properties and causal powers distinctive of that particular kind of fermions. However, they do maintain a very high degree of indeterminacy insofar as there is an extremely wide variety of more complex kinds of matter that they might go on to constitute. They do not flit back and forth past every possible value on the dial, but they do still flit past most of them. A fermion qua fermion can be a constituent of water, of a stone, a dog, or what have you. Now, water and stone themselves, by contrast, are like a needle that has settled down to flitting only across a very narrow range of possible values on our imagined dial. Water may take a liquid, solid, or gaseous state. Stone may be arranged into a pile or used to construct a wall. Compared to a fundamental particle, though, there is relatively little transformation they can undergo consistent with remaining what they are, namely water or stone. So whereas prime matter is the pure potentiality to be any material thing, fermions have a somewhat narrower range of potentiality, and water a much narrower range. Now, hylomorphism's treatment of the lower level material constituents of a thing as a kind of potentiality requiring actualization by higher level features is one of its essential differences with the mechanical philosophy, which treats all the material constituents of a thing as equally actual all the way down, rather than merely being virtually in the whole. And here, quantum mechanics is clearly closer to hylomorphism than to the mechanical philosophy. Indeed, the neo-Aristotelian character of quantum mechanics was recognized by Werner Heisenberg. Echoing the hylomorphic account of the relationship between prime matter and fundamental particles, Heisenberg writes, this is in his book Physics and Philosophy, he says, quote, all the elementary particles are made of the same substance, which we may call energy or universal matter. They are just different forms in which matter can appear. If we compare this situation with the Aristotelian concepts of matter and form, we can say that the matter of Aristotle, which is mere potentia, should be compared to our concept of energy, which gets into actuality by means of the form, when the elementary particle is created, unquote. Regarding what he calls the statistical expectations that quantum theory associates with the behavior of an atom, Heisenberg says, and here's another quote from the same book, quote, one might perhaps call it an objective tendency or possibility, a potentia in the sense of Aristotelian philosophy. In fact, I believe that the language actually used by physicists when they speak about atomic events produces in their minds similar notions as the concept potentia. So the physicists have gradually become accustomed to considering the electronic orbits, etc., not as reality, but rather as a kind of potentia. And again, Heisenberg says, quote, the probability wave of Bohr, Kramer, Slater was a quantitative version of the old concept of potentia in Aristotelian philosophy. It introduced something standing in the middle between the idea of an event, and the actual event, a strange kind of physical reality just in the middle between possibility and reality. To be sure, Heisenberg's way of expressing the point needs tidying up. For one thing, he appears in these passages to contrast potentia with reality. But as I've said, for the Aristotelian, potentiality is itself a kind of reality, albeit one that's distinct from the reality that is actuality. Indeed, Heisenberg himself clearly agrees that potentia, as he calls them, have a kind of reality. For elsewhere he notes that they are, quote, completely objective and do not depend on any observer, unquote. Heisenberg's identification of mere potentia or pure potentiality with energy also needs qualification. On the one hand, as the Aristotelian philosopher David Oderberg has suggested, if we think of energy as having no determinate form in itself, then one might be able to argue that it is identical to what the Aristotelian would call prime matter, though Oderberg himself refrains from such a proposal. On the other hand, as philosopher Stanley Grove has pointed out, energy is quantifiable, whereas prime matter, being wholly indeterminate, is not, in which case energy would be best interpreted by the Aristotelian as a kind of secondary matter that is at least one structural level above that of prime matter. Okay. Philosopher Robert Koons identifies several further respects in which quantum mechanics might be said to support an Aristotelian conception of matter, yielding a synthesis that Koons labels quantum hylomorphism. First of all, the Copenhagen interpretation treats microphysical phenomena, and in particular the position and momentum of a particle, as merely potential apart from interaction with macro-level systems, such as observers who measure the micro-level phenomena. Hence, like hylomorphism, the Copenhagen interpretation implies that the microphysical level is not metaphysically more fundamental than macro-level objects, nor sufficient by itself to ground all facts about the macro level, about the higher level properties of a system. Rather, the macro and micro levels are mutually interdependent, just as the Aristotelian claims, in holding that substantial form and prime matter are sort of mutually interdependent aspects of a complete substance. Second, there is the holism implied by quantum entanglement phenomena. The properties of a system of entangled particles are irreducible to the properties of the particles considered individually, or their spatial relations and relative velocity. The whole is in this sense more than the sum of its parts, just as it is on the hylomorphic account of a physical substance. Third, quantum statistics treats elementary particles of the same kind as indiscernible and essentially fused within a larger system, thereby losing their individuality and merging into what's sometimes called a kind of quantum goo or quantum gunk. As philosopher of physics Dean Rickles puts it, in quantum mechanics, such particles, quote, are really excitations of one and the same basic underlying field, and best thought of as dollars on the analogy of dollars in a checking account rather than coins in a piggy bank. They can be aggregated but not counted and distinguished as discrete entities. Now, this echoes the Aristotelian position that the parts of a substance exist in the substance virtually or potentially rather than actually. They're not nothing, but they're not actual either. There's a kind of potentiality or virtuality there. Stanley Grove, a philosopher I mentioned earlier, proposes that the wave-particle duality famous from quantum interference phenomena reflects precisely the greater indeterminacy that matter exhibits the closer it is to the level of prime matter, the more it flits across the dial, to use my analogy. Hence, a photon can readily flit back and forth between wave-like and particle-like manifestations in a way that a cow cannot readily flit back and forth between cow-like and hamburger-like manifestations. Because particles being closer to the level of prime matter are, to use my analogy from earlier, like the needle on a dial flitting across a wide range of possible values. By contrast, a cow is far from the level of prime matter insofar as there are several intermediate levels of kinds of physical substance between it and prime matter. For example, purely vegetative substances, or middle-sized inorganic substances, or particles of greater or lesser complexity. Those are intermediate levels between the basic particle, say, and the cow at the highest level. A cow is like a needle that flits only across a very narrow range of possible values on the dial. And as Grove notes, the probabilistic nature of quantum events also reflects proximity to the level of prime matter. Again, the closer a substance is to the level of prime matter, the greater its indeterminacy, its tendency to flit across the dial, as it were, and thus the greater its unpredictability. So the extent to which quantum mechanics describes systems having this kind of indeterminacy or potentiality in their nature, the more it seems to recapitulate the Aristotelian view of matter at the fundamental level as being the pure potentiality to take on form, to be this way or that. Grove also points out that the abrupt or discontinuous changes described by quantum physics, such as an atom gaining an electron or an electron being boosted to a higher energy level within an atom, are reminiscent of hylomorphic substantial change, which is also abrupt or discontinuous. The gain or loss of a substantial form is all or nothing, unlike the gain or loss of an accidental form, which could be continuous. Now, the mechanical philosophy, as I've indicated, essentially reduces changes that the Aristotelian regards as substantial changes to accidental changes, and thus interprets what the Aristotelian would take to be discontinuous transitions as, in fact, continuous ones. Insofar as quantum physics affirms abrupt or discontinuous transitions, it confirms an Aristotelian rather than mechanical philosophy understanding of matter, at least in a very general way. Finally, Heisenberg's famous uncertainty principle is also, in Grove's view, something that should not be surprising on a hylomorphic conception of matter. A particle's momentum implies a potentiality toward a range of possible positions, and its position implies a potentiality toward a range of possible momenta. But since momentum and position yield only potentialities rather than actualities, we should expect that knowledge of the one will yield less than certainty vis-a-vis the other. Now, summing up the implications of the results of contemporary physics for the dispute between the mechanical philosophy on the one hand and Aristotle on the other, the late Stanford philosopher of science Patrick Suppes wrote, quote, "The empirical evidence from macroscopic bodies and also from high-energy particles is that the forms of matter continually change. There's no reason to think that there is a spatial buildup of electrons, for example, from some more elementary objects. The collisions of electrons and other particles to produce new particles, as observed, for example, in a cloud chamber and other experiments, is simply good Aristotelian evidence of the change of form and matter, a form of matter. The cloud chamber data especially support Aristotle's definition of matter. As we observe change, there must be a substratum underlying that which is changing. What is the substratum underlying the conversion of particles into other particles, or the conversion of particles into energy? The answer seems to me clear. We can adopt an Aristotelian theory of matter as pure potentiality. The search for elementary particles that are simple and homogeneous, and that are the building blocks in some spatial sense of the remaining elements of the universe, is a mistake. And that's essentially the view of the mechanical philosophy. To end then, some Thomist, and I think it was the late Ralph McInerney, but I've been unable to track down the quote, and so I'm not sure, once remarked, quote, "Whenever you've got a new idea, read Aristotle to find out what's wrong with it." Of course, that's an exaggeration. Some new ideas are good. But sometimes when they're good, it turns out that they're not really new. And so arguably, the example of quantum mechanics suggests another maxim. Whenever you've got a new idea, read Aristotle and find out if he already thought of it. All right. And with that, I thank you for your patience and attention.